Hey, Joe, welcome back.
Thanks, Adam.
Good to see you back in town.
Yeah, it's good to be back.
Excellent. And, well, hey, thank you for the continued sponsorship. We appreciate that.
Oh, so it's my pleasure. Thank you.
You have been, well, you were one of our first and continue to be in there supporting the podcast, and we hope it helps getting the word out.
Well, I tell my kids it's a podcast, if you don't mind.
It is another podcast. You ended the last one with that. This will be our second podcast. No, that's fantastic. When were you out here? August?
Summer. Yeah. It was warmer.
It was warmer. It's not too bad. We don't have snow on the ground right now.
No, that's true. It feels cold, though, being wet and windy.
What's it like in Greenville right now?
Oh, goodness. 78, sunny.
Yeah.
It's our first false summer.
Oh, right.
Yeah, the redbuds will come out this time of year, and it looks really pretty. But, you know, we'll have 2 or 3 more times of cold and then back to warm again. So,
all right. Well, you'll be back to the warm soon.
Pollen season coming up.
You get 2 of those then?
No. Well, that's 365 days a year feels like pollen season there.
Okay. It's always something in the air.
Yeah. Sneezing all the time.
Oh, I like Greenville.
Yeah.
I like Greenville. It's a nice place.
Don't tell too many people that, though. We're trying to keep it a secret.
Same thing I say about Tehachapi, and then I come out here and I advertise Tehachapi and talk about it.
I know. They're both great places to live, but we're having a lot of people move in, so.
I see. Well, we'll have to get the code enforcement guy to stop permitting the new houses or something.
There you go.
Right on. Well, what have you been up to since we saw you last?
I've been trying to grow the business, diversify it a little bit.
Okay.
So taking on stuff similar to renewables. Electrical engineering is needed in many, many different places. So probably since the last time I've gotten into some agricultural stuff, dairy farming, which I guess that's renewable. I mean,
all right.
They have to. So in the great state of Oregon, I've been doing some projects up there. Massive dairy industry up there in that area. So a lot of power quality stuff. Power quality is kind of a broad topic. It's very important in the renewable space with NERC and other types of issues, harmonics. So that's very common to what I've been doing, a lot of power quality type things. So you notice I have eyeglasses now. You probably didn't notice, but I have hearing aids.
I didn't.
So since the last time, I've ended up getting both. And I knew my vision was getting worse, and I knew my hearing was getting worse. But I didn't really know how bad until I got it tested. So power quality is a lot like that. You can go get it tested, and that's something that I've started doing, is testing it, recording it, documenting it, and showing people where their issues are, particularly with power factor correction or harmonic mitigation. And then, just like the hearing aids, there's a prescription. My hearing loss was at 4 kilohertz, and the audiologist says that's damage, not age. So, yeah, I mean, I'm getting older, but that was exactly where I needed to be raised in my spectrum. So it helped a lot with tinnitus and other stuff. So power quality, I think, is very similar, where I can come in to a facility, to a site, renewable site, measure it, and offer up improvements as to things that could be done to mitigate the harmonics, because there's a standard called IEEE 519 that all utilities, not all of them enforce, but it is the standard for harmonics and how much total harmonic distortion you're allowed to have and things like that. So after I do that, I recommend some hardware. Sometimes they'll put it in, sometimes they won't. But the damage that can occur from harmonics can be magnetic circuits, particularly transformers. So, in the solar application or wind application, we try to filter those out at the inverter or converter, right? We'll put a line filter in. But that's a passive device, and we're able to tune that because we know their switching frequencies of RGBTs. But then when you put a bunch of them together, and then you have the system, the utility harmonics, and everything, it's a lot different. So you have voltage disturbances and current disturbances. So sometimes there are things that could be done in an active harmonic filter to fix that as well. So like an active harmonic filter, if somebody were hitting this at a regular interval, the active harmonic filter would come in and hit it on the other side at the exact same frequency. So if you're having a lot of third, fifth, seventh, ninth, typical odd harmonic content, the active one will use IGBTs most of the time to inject that signal equal and opposite of what's coming in, and it cancels it out. So it's a great way to mitigate a lot of power quality issues. Hearing aids and noise cancellation, stuff like that works very similar. So,
okay, Padge is now the power quality doctor, since you compared to ear and eye, and they get the doctor title. So I think Joe, the power quality doctor, should be born.
Well, power quality is important to the utility, and not all amperes are created equal, right? So 1 amp is not always 1 amp, but it might be 1 amp at 60 hertz. But when you start looking at it, the additive effect on it, that's just not the case. So, you'll see this in wind bus bar and wind cabling coming down, right? There's a lot of harmonic content on those cables. And we ended up, you oversized them for the harmonic content sometimes because it's just not pure 60 hertz, right?
No. Okay. Right. No, you have variable speed.
Yes.
Okay. How does power quality come into play in the dairy farm? I understand the need for electrical engineering and electronics, but how does power quality affect? And I don't know much about factory farming dairy, which I assume we're in this conversation, but there's moving parts probably for collecting and processing.
Yes. Okay. So at a dairy farm, you're going to have your pens, you're going to have your parlor, you're going to have your milking barn, and then you're going to have your barn in and of itself, right? So you're going to have all of those different things, and you want to keep the cows as comfortable as possible. So you have a lot of ventilation. And ventilation in modern times is run off variable frequency drives. So variable frequency drives are going to introduce harmonic content into any system. And then when you exceed your total harmonic distortion per IEEE 519, that's when you want to put mitigations in place. So there's all kinds of rules of thumbs for people putting in VFDs. Wind turbines have VFDs for some cooling applications. I've seen solar inverters with variable frequency drives to cool their IGBTs. So HVAC is a very common place for variable frequency drives. And if you don't do anything about it, you're going to have these wicked-looking wave curves that go back and reflect it back to your utility. Because on a VFD, you got something, most of the time you got a passive front end. It's called a 6-pulse diode. And that 6-pulse diode just has awful reflective harmonics back to the utility. You can do an active front end with IGBTs too, and then you can have power going backwards and forwards. That's the way EVs are where you charge, right?
Right.
Through braking, so same principles. But again, you still have power quality issues with those as well.
On the dairy farm, does it lead to HVAC failures then, or?
It leads to overheating. So the biggest issue is non-compliance with 519, but then overheating. So conductors will overheat, magnetics will overheat, transformers. So many people will elect to buy a transformer that's made specifically for harmonics. So that is called a K factor. So you'll get like a K factor 4, and a K factor 4, it just happens to work out that it's 400% more capable of handling the thermal load of a normal non-harmonic type transformer. So if you have if you have people losing transformers in a renewable application, one of the first things I'd like to look for is heat, and is the heat as a function of harmonics, or my ventilation suffering or something like that. But oftentimes it is harmonics.
Wow.
It's like the hearing aids. You don't know it's going until you go get tested.
Right. Don't know till you test. Don't know till you test is a theme in a lot of areas.
Yeah.
I think what it's interesting, and you brought last time, the growth of AI, the server capacity, new demand on the electrical grid, new demand for how to manage the power, how to control the harmonics. We have heat issues, and now you see it in agriculture as well.
Yeah, these are state-of-the-art facilities.
Okay.
Very, very impressive.
Wow. No, this is it's interesting. Did you start in aviation?
I did.
Was that aviation to renewable to agriculture?
Yeah. I left the space shuttle program
Yes.
after the Columbia accident. So yeah.
Right. Yeah, it's needed everywhere. New problems everywhere. So you're running into similar problems, maybe from an electrical engineer's perspective, but in new areas.
Yes.
I'd like to take this time to thank another one of our wonderful sponsors, Padge Engineering. Padge Engineering, making wind and solar all we know it can be. Are your renewable energy assets underperforming or not performing at all? Did you expect many years of longevity and they're failing on you now? Padge LLC offers many customized, engineered products and solutions to get these assets back on track. Padge Engineering also performs root cause analysis, engineering services, procurement, and construction. Visit podge.org. That's PADGE.org. Remember Padge, making wind and solar all we know it can be. All right. Well, what are you seeing new in renewables then?
I'm seeing a hectic schedule, busyness, lots going on in the solar space. They're getting bigger. DC voltages are pretty consistent at 1500 volt. I'm seeing a lot of people contemplate the string inverters, but the central inverter still seems to be very dominant. A lot of overseas manufacturers. I mean, for the most part, you have a lot of U.S. support, but as these inverters have gotten larger, and I'm just going to pick a number that seems pretty reasonable. Let's say 1500 kVA, okay, for a central inverter.
Okay.
That 1500 kVA mark. There is a reason in electrical engineering when you're doing a design, for instance, there's a stopping point on kVA or amperage where you generally like to stop at and consider going to a different voltage. So that 1500 to 2500 kVA region is a point where generally, if I were doing like the dairy facility, I would split it up into 2 or 3 or 4 different services to keep the kVA lower, right? In fact, I'll just say this. When I do stuff that's not related to renewables, I always stop at 2500 kVA. It's hard to get a utility transformer higher than that. So you run into a myriad of technical problems and safety problems that you just don't need, unless you're able to keep it below that. So that's for low voltage applications. Once you get above that, then you can consider medium voltage applications.
Where do we see 1500 kVA?
In solar now, that's ubiquitous. There's nothing smaller than that anymore.
Wow.
I'm seeing 4,400 kVAs
Wow.
out there. Yeah. So at anywhere from 630 volts to 690 volts. So the 1,500 kVA system, was something that GE Wind and others introduced over 20-something years ago. So, now you've seen that some of the other products that GE, for instance, coming out, 3-4 megawatt, 6-3 megawatt. But you will also see that they've considered the voltage level for a lot of those. So, like I said, you got technical reasons, and then you got safety reasons. The technical reasons, your engineering company is going to look at the advantages, the pros and cons of that. Just getting that many number of cables in, for instance, can be an issue.
Right.
Sometimes you can have to put 15 to 18 cables per phase. That's a large duct bank, right?
Yep.
So the electricians are going to be happy. So considering going to a different voltage is good there. But the safety reason is the incidental energy that we're seeing on some of these is getting well above 40. Excuse me.
Yeah.
So I know people love to stop at 40 calories per centimeter squared, right? Because there's NFPA 70E generally stopped at that for years. They no longer stop at that. You can go, if you can find the equipment or the PPE to wear, then yeah, you can do that. But you get into other issues with safety when you go above 40 that aren't always related to thermal energy, okay? So you can protect yourself thermally from the burns, but what about the percussive energy? Some of that acoustical energy can bruise internal organs and things like that. So that is one of the things I've seen a lot over the last year is some of those KVA ratings getting a little higher. And quite honestly, I'd like to see them go back down a little bit or consider a different voltage on the AC side.
And we're seeing it. So you related it to the calorie suit, but so this means we have to put a human within a certain amount of distance.
Yeah, so in the arc flash label, you have the arc flash boundary and the incidental energy. And the incidental energy is not always, it's usually calculated at 18 inches, right? So an engineer such as myself could tell you how far you need to stand away to get below 40 calories, okay? Now, these calculations they're experimental. Okay, there's a lot that goes into these calculations, and I've blown up in high current labs all over the world equipment to get it to have what we call an ANSI C37.20.7 designation. Okay, so ANSI C37.20.7 means that your equipment can withstand an arc flash, and the person standing adjacent to the enclosure would not be significantly harmed from that arc flash. So in the realm of motor control centers, probably 3 out of 10 that are procured in the industrial space today are bought to be arc resistant. The other 7 out of 10 are not. Okay. In the renewable space and solar, 0 out of 10 carry that designation. In the wind space, it's a lot better than that. If you go into some wind turbines, you will see, and I hope your viewers go look at it, you'll see sometimes an ANSI C37.20.7 rating on it.
Okay.
So I would challenge the people listening to this to go look for that in some of the wind turbines on the inverter and then see what it says. It'll have a number and a letter. It'll be something like 1B or 2B or 2D or something like that. And that'll define the safety of the enclosure with respect to front, back, sides, and intercompartmental damage. Okay. So here's what happens with MCCs, solar inverters, wind turbine converters. You'll have a arc flash and a benign part of the enclosure, okay? But because everything is so compact and high density, we're trying to fit 10 pounds of stuff in a 5-pound box.
Right.
Okay. That small arc will then propagate and get into the service entrance very quickly. Okay. And once it gets into the service entrance, there's nothing there to stop it except the expulsion fuses on the transformer or the relays that are upstream at the substation. Okay. So you will very quickly get above 40 calories at that point. So the intercompartmental piece is very important because you're saying that if I have something in compartment A, that it doesn't carry over to compartment B. So if you're out there working on a solar inverter and you think that you're safe over here, that's not the case. It could very quickly escalate to go over there in just milliseconds. 60 hertz is 16 2/3 milliseconds. Nobody has a reaction time that fast.
No.
Our reaction time that we put into arc flash calculations is 2 seconds. So if the breaker won't clear it, we say it clears in 2 seconds. Now, it really doesn't clear. Suppose you fall down.
Right.
Yeah. So anybody listening to this, I hope they take that to heart, that, something that looks benign over here that could be 24 volts can very, very quickly turn into 60, 70, 80 calorie incident by who knows why. So if it doesn't have that ANSI C37.20.7 on it.
Say that slower.
ANSI
337.
C.
Oh, C37.
.20, C37.20.7.
Okay.
Okay. And then you have different letters that go with that. Now, that's a North American standard. If you're in Europe, you're going to look for IEC 61641.
IEC
61641.
61641.
Why do I remember these numbers? I don't know, but they seem to stick with me for some reason.
And the ANSI in USA, C37.20.7. If I wrote that down right.
You said it right. Yes, sir.
And if I understood that, what would it mean to me if I found it on a cabinet and took a picture?
First of all, that's going to give you a that enclosure has been specifically tested to withstand the fault current that it's going to be subjected to that results in an arc flash. Okay, that's called arc resistant gear.
Arc resistant gear.
Okay, so many young people and older people coming into the field of electrical. Some people assume that the door being closed or a piece of Lexan or something like that keeps them safe. That does nothing. I mean, that's like trying to feed a Tic Tac to a well and expecting the well to get full from it. I mean, I've seen doors blown 30 feet off a solar inverter. And I mean, if that hits you,
yeah,
you're
game over.
Game over. I mean, so can PPE protect you for that? No, right? So there's other dangers besides just thermal dangers.
I was just thinking, we've been working on some giveaway programs. I think that we should do one for submitting pictures of your ANSI C37.20.7 with a little description of what it means to you when you see it. And then we'll get them in a raffle and we'll give them something, Jacob.
Yeah.
That's a good one.
Most of your people are going to see arc flash labels. That's not what he's looking for.
Not the arc flash label.
It's not the IEEE 1584 and FPA 70E arc flash label. You're looking for the arc resistant label that says your gear is rated to withstand that incident. And I'll give you some hints to look for.
All right.
Many times you're going to see chimneys or plenums, if you will, to redirect the energy away from an operator. In many cases, this incidental energy is as hot as the surface of the sun or equivalent of a Tomahawk cruise missile.
Tomahawk cruise missile.
Yeah. So the military, I was told, because I have customers who do that, they told me they've taken a lot of lessons learned from making arc-resistant gear to using it to protect Humvees and other equipment like that. So I'm glad those things are getting incorporated.
Right. Will all equipment have that ANSI rating?
And solar, I've never seen one.
And solar, you've never seen?
Yeah. And wind, I've only ever seen one OEM do it.
Okay.
Yeah.
What does it mean to a technician that walks up and doesn't see that then?
So you're going to want to see an arc flash label.
Okay.
There. You're not even required to put an arc flash label on either, right? You can look
Didn't know that.
You. I reluctantly say that, right? I prefer that you always do an incidental energy calculation. And when should somebody work on something hot? Never. Never. There's no reason to ever, right? But sometimes you have to troubleshoot hot. But some of the stuff that I've seen come out that's above 1500 kVA, you can't even troubleshoot it hot. So you have to get your fault codes and everything and then guess what might be happening because you can't take a meter to it. So I forgot your question. And I think I answered it, though.
I think so, too. I think what I'm trying to get at is there are so many different components, wind, solar, battery, that require a certain level of PPE, a calorie-rated suit, gloves, things like that. There's a lot out there, right? And how the technician identifies, well, is it 0 cal? Is it 28? Is it 40? Where am I at? And they have to go to the drawing to calculate it?
So
it's not on the sticker?
Well, here, I would challenge that way of thinking all day, every day. Okay. Because when you're talking PPE, you've already skipped over 4 other important parts. Number 1, can I eliminate the hazard? Number 2, can I substitute for the hazard? Number 3, can I have an engineering control to mitigate the hazard? Number 4, is there an administrative control I can do? When you get to the last one, PPE, you've already said, I can't do anything for those other 4. And that's just not true. That categorically is not true. I have never seen one where the incidental energy couldn't be mitigated through engineering controls or substitution. There's so many things that engineers can do, not just my company, but other companies, to take stuff that's 80, 90, 100 calories per centimeter squared to 0.1, 0.2.
Wow.
Yeah. So, but I don't think people are aware of it. And it does cost a little bit, but not a lot. Not a lot. But when you say that, when you see the arc flash label, that gives a person an idea of how dangerous the equipment is. So if you see anything over 40, old NFPA 70E, we'd call that hazard risk category 4. And historically, when I do my arc flash studies for customers, I make my software take, when it calculates something above 40, it makes the label red and it puts a danger warning on it instead of orange with a warning label on it. And I've noticed that all professional engineers tend to do that as well. Okay. But it begs the question is, what could be done to reduce that incidental energy? And you and I don't have enough time to talk about all the things, but people can certainly call me or call any professional engineer that works in this space. Safety is too important to not go above 2 levels above PPE just to engineer controls or even substitution or something like that.
This episode brought to you by RST Cranes. With over 30 years of experience, RST Cranes brings the industry expertise to every project. From wind turbines to solar inverters, mining operations to industrial construction, RST Cranes is your heavy lift specialist, located in Tehachapi, California, and serving the surrounding areas. Contact RST Cranes for your next project at www.rstcranes.com. I agree 100%. Didn't ever want to skip over engineering out the risk. But in solar, you need the gear to even check sometimes.
The way most of them are designed.
Just to verify, even.
Yeah, the way most of them are designed, that's very true. But that there's going to be cases where the PPE doesn't exist. I mean, I've never seen a 250, 300 calorie suit.
So I couldn't wear like 5 or 6 40 cals? And
No.
No?
No.
All right.
Well, like I said, there's more dangers besides thermal.
Right.
Percussive, flying objects.
Yeah.
So many different things that are going on there.
I guess I ask because I hear a lot about solar and the different rated gloves and suits and things like that to go perform a task, say, even if it's verification. Mm-hmm. And we're calculating off of the drawing.
Yeah.
I don't know if are there stickers on them that tell you what to wear?
Yes.
Are there?
99 times out of 100, there's going to be an IEEE 1584 arc flash label that's put on it. Now, here's what I'm going to tell you, though. And if it doesn't carry that ANSI C37.20.7 rating on it, a lot of times you're going to have a DC side arc flash study and an AC side arc flash study. And it's going to give the impression that, the DC side is only 35. Mm-hmm. The AC side is 235 or something. Does that mean the DC side, you can go test that and verify it? No, that's not what it means. Don't do that.
Right.
The entire thing does not have intercompartmental arc resistance to cover it from an ANSI C37.20.7 rating. So you're exposing yourself on that side that had that study done. So I would challenge, if there's professional engineers listening to me, just put the highest rating on the device, okay? The only way to separate the two is if they were in two different enclosures, okay? But when they're all designed under one enclosure, and that's one of the downsides to a central, inverter, is it's all there in one enclosure. Mm-hmm. So sometimes in wind, you'll see switchgear separate from everything. And the one OEM that did do the ANSI C37.20.7, they did a very good job of that intercompartmental carryover.
Okay.
So if a PE was doing the arc flash study on the control side, yeah, you could go work on that. Should you? If it's less than 50 volts, yeah, you can. But you can troubleshoot and do things like that aren't called work, right?
Right. Terminology a bit there.
Yeah.
Okay. Well, great. Sounds like a great advice and some extra encouragement for engineers that are having the task of designing and putting these together.
Yeah. So I brought a piece of equipment with me, just one of many ways to engineer an engineered control to do a lotto where you need to do a verification that is, greater than 40 calories. So it's a remote terminal device. So what, I know people are probably listening, mm-hmm. but this piece right here, think of this as the enclosure. Okay. This would be the enclosure. And then these conductors here are going to go off to the part that you're going to want to verify. Okay. I would definitely recommend getting engineering guidance and installing this, because you sometimes are going to need fuses to adhere to something the code calls the tap rule. Okay. But once you put this in, this is a high impedance path where you can do a live, dead live check to verify that you've indeed shut down your equipment. And what I like to do is when I install them is put them far, far away from the arc flash boundary. So if I got an arc flash boundary of 20 feet, then this device is going to go somewhere else where they can take the measurements there. So otherwise, if you're shutting down a solar inverter, how are you going to, where's the next place to verify it? At the substation.
Oh?
Yeah. And why would you want to expose yourself to 34.5 kV verification, with a hot stick high up in the air or something like that, where you're introducing other risk? So this is one of many things that my company's trying. Please, we're trying to push to help keep people safe. So what I like about that device is when you're energized, you have LEDs that flash. Okay. So then when you go through your switching procedure, let's say you're switching off the oil switch, you can see the LEDs go off for all three phases. And then you can bring your fluke or whatever meter, put it in there, and you can verify, line voltage at that point. So it works for AC or DC. So we go up to 3,000 volts DC.
I'm lost a little bit on where this goes. I understand this is connecting to whatever source or supply you want to be checking, but we're talking about for a central inverter?
Central inverter.
And we would mount it where?
So I would put that in another enclosure far, far away. Let's say my danger is 20 feet away from me.
From the central inverter.
From a central inverter. My bus bar is over there, and I have to go verify that it's de-energized. But when I get 18 inches away from it, the incidental energy is just, let's say 290 calories per centimeter squared. I can't put PPE on to go verify that. But if that device is already installed and it's an engineered control, it's connected to that bus via engineered solution with fuses, wire size, everything like that, and wires are running 20 feet away to another enclosure that's permanently mounted, then you can measure it. So we've done studies to show ROI and payback on that thing. But that's just a remote voltage verification point that is commonly used.
And it's visual.
It's visual, and you can put your meter into it.
Sure. How is it done today without this?
Well, so what they should be doing is verifying it at the place, basically at the substation. That's the only place to do it.
Is that okay?
I don't think so. Because solar techs, and I've heard other guests on here talking about that, they're expected to know substation. They're expected to know cutting grass,
Right.
MC4 cables, all of these different things. And it's just, wind is significantly more mature than solar in this instance, because you'll have generator people, you have major component exchange people, blade people.
More specialized.
Yeah, a lot more specialized. And solar will catch up.
Sure.
It's just growing right now. So I'm hoping to make a difference with things like this. Whether I benefit from them or not, I want to see the industry do well.
Right.
Right. So a lot of these engineered controls, and this is one of probably 5, 6, or 7 that I'm able to do. And this one's just related to lockout, tagout, right? And this is a very cheap solution. I'd much rather sell one to reduce the incidental energy.
How would you do that?
Well, I keep it a little close to my chest.
Okay, but you have it.
But it does work.
Where else could you use this outside of a central inverter?
You can use it in any place where you have where you want to do a verification without having to expose yourself. Have you ever heard of a Chacon switch?
No.
Okay. So a Chacon switch is similar in terms, let's just say you want to go open a piece of switchgear. Okay. And you know that you're going to open that piece of switchgear, you're going to expose yourself to some astronomical amount of incidental energy.
Okay.
So what you do on there is you hang a device, and it's motor operated. And then you come away from it, away from your arc flash boundary. You push the button. It turns the pistol grip. Your breaker opens.
Oh.
So, Chacon.
That's a Chacon switch?
It's called a Chacon. Well, Chacon switch was one of the first companies to make them. It's kind of like the Heimlich maneuver. We don't call it abdominal thrust now. So I still call it Chacon switch. I'm not really sure what it's technically called.
It's because, are you too chicken to go switch that?
Yes, exactly. Exactly.
I wondered.
That's where it came
I don't know
from.
if we're going back to agriculture. No. Okay. All right. I got it. So this would prevent the person from being in potential harm's way when verifying for Lotto.
Yeah. One way to think about it, let's just say you have an enclosure that's got a hazardous gas inside. Do you want to put your nose inside to smell it? Or would you rather have something tell you from the outside, you have 14% oxygen in here?
Yeah.
Something like that. This is the same thing. It goes far away, you know. Now, can you use SCADA to do this? No.
No, you just have no communication, perhaps. Yeah.
Well, and OSHA doesn't allow it.
Oh, sure.
Yeah. So there's
not for actually work.
Yeah. I mean, I'm sure there could be things that engineers could come up with to allow some type of software to monitor it, because you have these things called safety integrity levels that go all the way up to safety integrity level, SIL 1, 2, 3, and 4.
Safety integrity level.
So like take, for instance, a pitch system on a wind turbine. Mm-hmm. It's designed to be a SIL 2 type device most of the time. So SIL 2 means it has a probability of failure on demand, something like 10 to the 9th opportunities before it fails. Aviation, it's usually SIL 3, SIL 4, stuff like that.
Okay.
But, you know, only in offshore wind have I seen stuff like consistently do SIL 2. Safety chains are SIL 2. Well, actually, they're SIL 1. I take that back.
Okay.
Yeah. Some people have even made them SIL 0. but I've seen some that were SIL 2.
We'd like to thank our sponsor, Altair Energy Services, and their highly trained, expert technical staff, leveraging decades of renewable power management experience into customized solutions for everyone to meet their energy goals and contribute to a better future for all. Altair's team of hardworking, respected experts are providing full-scope, turnkey repairs, planned and unplanned maintenance, system upgrades, fully autonomous technical crews, supplemental staffing, and customized dynamic scheduling to fit your power production needs. Contact Altair at info@altairenergyservices.com and learn more about their wide range of capabilities across multiple power technologies and platforms. I mean, what else can you tell us? What are you seeing out there with Lotto and, I don't know, common work practices maybe that you see we should talk about?
Yeah, I still see a lot of confusion.
Yes.
Even in the year 2025, we're recording this, I still see a lot of confusion on Lotto.
What do you see?
Well, there's 6 steps to Lotto. There's PSI, ACV. That's the way I remember it. PSI is like pounds per square inch, and ACV is like AC voltage. So those 6 letters stand for prepare, shut down, isolate, apply, control, and verify.
Wow.
Okay. So I see the part that everybody gets right is the apply part, right? That one's easy. Hang your lock. And most people get so concerned about the paperwork and everything that goes on along with that.
Right.
Why
is that?
Well, I mean, that's the first thing people go to when there's an incident. And unfortunately, as somebody who does a lot of incident investigation, those are the first things I ask for.
Yep.
Because they tell a story.
Right.
It's like a black box on a airplane. But the prepare phase is probably the area where I see a lot of not necessarily, could be a lot more room for improvement.
Okay.
Prepare is a part of a culture
Yes.
phase. So if a company has pre-written lotto procedures, they've done a very good job on the prepare phase. Okay. If a company does not have them, that doesn't mean that they haven't done as good a job. They might have simple lockout, tagout procedures. But if you've gone through the rigor of preparing a lockout procedure, then I think you've done a very good job on the prepare phase. That's going to force the technician or engineer who's ever working on it, to go through all 6 steps and understand, what's going on. They're going to have a training program associated with it. You're going to do hands-on demonstrations. And then you're going to have an instructor that's going to try and trick them up.
Right.
Yeah, I think it's great when an instructor slips in something. Like if you really want to throw somebody off, in a classroom environment, they go open a 3-phase switch, have one phase get stuck, something like that.
Yeah.
And then see what your class does. I think that's a great way to because you're doing it in a safe environment, right?
Yeah.
Where you can do that. But those things do happen. So that's. I mean, I'd love to know what you interview so many people, and I hear so many of your guests on here and talk about safety.
Yeah,
and it's been one of my theme words for my business for this year.
Okay.
Because I want to see it, at least especially in renewable space, get better.
Get better.
Yeah, I even felt bad about monetizing it. But, people sell lanyards and stuff like that. There's no reason people have to get hurt.
I love that.
Yeah. I mean, I understand you're still going to have injuries and accidents and, 3 out of and we engineers quantify those. We always know how many people. So when you say 0, there is really no such thing as that. But you can asymptotically reduce that to 0. That's our goal. But it takes a culture.
It takes a culture.
Mm-hmm.
I don't know where you see the confusion. A lot of times it is the amount of training that the person got,
mm-hmm.
and then it's who trained them. We like Rise Renewables, and we know the training they do, and we talk about them a lot, and they're always in here sharing, new safe information. And
I love their passion too.
I love their passion. Yeah, it cracks me up. They never talk about the training. They talk about safety. I'm like, you guys, you're training them. But they're, this is their answer to safety.
Yes.
It's more training.
Yes.
It's better training,
mm-hmm.
And from the right people.
Mm-hmm.
Most new techs get training on the job,
mm-hmm.
which can be fine if you have the right trainer with that person on the job. And I worry that we don't have enough of those in the industry right now, walking around and taking the new apprentice under their wing and teaching them. I don't know. My observation.
No, I think you're spot on. There's a lot of companies out there that self-perform, do their own O&M. I have quite a few wonderful, wonderful customers.
Sure.
They do the best they can.
Mm-hmm.
I've been an engineer. I've been in management, and if you ever go work on a car, and I know you like cars, and you ask yourself, what engineer put this here or made it so difficult to work on, right? Well, that's the perspective of the mechanic, right? When you're an engineer, you're going to say, what manager put me in this position to have to make this where I know it's going to be difficult to service, okay? I don't think any engineer worth his salt is going to want to do that, right? Now, I've been a manager, and you ask the question, why is my company, or why are my customers, or why is this government regulated? Why am I doing this and having to pass this along to my engineers that are designing it, or to my techs that are working on it? And in our space that we love so much, there's just so much demand right now that I think it creates that culture.
A bit of pressure.
A bit of pressure.
The other side of it. Technicians are very result-oriented people, hands-on people, wanting, the job satisfaction comes from seeing power produced, no matter what you're fixing, because that's what we do. And so that pressure, even internally in this type of this type of person, is to get the job done. And if you don't know, you got to stop. But I know that kind of pressure exists.
It does, and it exists at every position, and especially in solar, because there's just so many new installations going up. It's mind-boggling how many I see.
The one thing that we try to embrace is use, communications we have. It's so nice. I mean, cell phones and earbuds, and call your mentor or subject matter expert and getting advice real time isn't too difficult, right? You just got to do it. You just got to go, all right, time out. Quick pause. Need a little help. And I probably know who to call, or that person will know who to call. And you can get some help and get the right information. So, not trying to put any blame anywhere, but you're right. It is a culture. And so if it's a culture, then everyone involved has to share that load a little bit. You and me included.
Yes. Yeah. Just us talking about it, it brings a lot of recognition to it. The other thing that I do see is because of that, before it even gets to the technician working on it, there have been some compromises made on the equipment, but just by the time it gets there.
Okay.
And that's because of cost, trying to get that put out. I worked for an OEM for many, many years, and we felt cost pressure. But we had a very, very robust engineering team and chief engineers that you would have friendly banter.
Sure.
It's like, really? Yes. And then you would work to a solution that would be agreeable. In solar, I think, I don't want to sound alarmist, but some of that friendly banter is won by the market and the prices dropping. So the level of safety quality from the way something can be designed is just not as good as it would have been on a wind turbine made 20 years ago, for instance.
Ooh, that's a gap.
Yes, it's a gap, but it could be remedied.
Right.
It could be remedied. That's why I brought this and talk about other things that can be done. It just doesn't all fall onto the OEM. Sometimes it can fall onto who builds the site. One beautiful thing about wind that distinguishes it from solar is wind is a very vertically, no pun intended, but very vertically integrated from a management perspective. Okay, the same company that may make the blades, it may make the pitch system, may make may make everything maybe in many cases. Or if they don't, they're tightly closed in on everything there. From a solar perspective, that's just not the case. You have a BESS supplier sometimes. You have a central inverter supplier. You have the cabling.
Oh, you have ice load OEMs.
Yeah.
Siloed.
Siloed.
Versus, you're right, in wind we saw it might be one, but they might have a subcontractor and they're in control.
Yeah.
Yeah.
Yeah. And so when it comes to performance and safety, that you're not always there. So the solar OEM's not going to, they're not going to do the ANSI C37.20.7 because they're not necessarily going to know what to test it to. Now they can tell you, this was subjected to 50,000 amps, at this voltage, and that's there. But they don't necessarily know how that's going to be applied. Right. So you have more pieces of integration that occur outside of that, and it's all about time and schedule.
And this is different independent engineers that are putting pieces together to make a power plant.
Yes.
In the field.
Yeah. I mean, some of them are 400 megawatts.
Yeah.
Huge.
I know a couple half gigs right around the corner.
Yeah, that's amazing, isn't it?
It's amazing.
Yeah.
It's one of them has panels this big.
Yeah.
Going a half a gig.
It's crazy.
It's not always on the OEM. You said something the last time you were here that I resonated with and I loved, and it's that you started off with ready, fire, aim, and that's the ready, fire, aim, right? And the OEM has to pull the trigger.
Yes.
Right. It has to happen, and then you have to celebrate some of the. Celebrate the failures, I think is what we said.
Yes.
Because then we have the opportunity to design an improvement.
We got some pushback from that, I remember, too. Good, friendly pushback.
Right.
Yeah.
Right. But it's true. And you as a power plant developer, you kind of want to get out of the OEM warranty period. You do and you don't. You don't because your financial performance said this is how we make money. But you do so that you can go and fix things tailored to your power plant.
Yes.
Right. And this sounds a bigger need in solar, since we're combining multiple OEMs to make this very unique very unique power plant.
Yeah. No, I agree with that statement. And I'll add one more thing to it since that last one that I see in solar and a little bit in wind. Is many people are very content with the devil they know versus the angel they don't know.
Yeah.
Now, I changed that expression up to say the devil they don't know, because somebody like myself who's coming in and saying, okay, I'm not going to sell parts. I'm going to sell an engineered solution that's going to improve performance and safety. Okay. But, I'm looking for a smart customer who's willing to pull that trigger on that and move with that. But sometimes many customers are hesitant for a variety of reasons. They have their own reasons. But when you have so much money and so much schedule compression being thrown in on a lot of these projects, after you've gotten burned a couple of times during the commissioning phase or the ordering phase, you are hesitant and reluctant. So I'm very patient with a lot of those customers, and because I'm having to show them ROIs and other things like this thing right here. I had a customer, it's like, could you help me with an ROI? So I did an ROI on one of my other ones. It paid for itself on the first lockout. But that's hard. That's a hard thing to sell.
Do you want to go into the how a little bit?
Yeah, I can talk a little bit about how.
Okay.
Okay. So if you look at any renewable asset that's been built in the last 15 years, almost all of them offer no secondary protection on the transformer. It's not required by code.
Okay.
Okay. In the early years, the OEM I worked for, we did put it in. Okay. And we took it out because it wasn't offered by code. I am able to put that in a fuse form. Okay. So many fuses. So here's the danger of putting a fuse inside a central inverter. And I talked about it earlier. Once you get an arcing event that happens, it'll arc over the fuse and arc to ground. So that does no good. You want it in a separate enclosure. Okay. So the pad mount itself is a perfect place to put that. And there's plenty of room to put them. These fuses are cube fuses. They go anywhere from 1,500 amps to 5,000 amps, up to 690 volt for the application. Okay, many people are like, well, Joe, what about the bayonet fuse or expulsion fuse on the primary like that? It's like, well, those are sized, astronomically high, and they're meant to protect the transformer. They're not meant to reduce the incidental energy on the other side. So what makes fuses special are two things. Number one is their fast response time. On a circuit breaker, you have to see the sinusoid pass through, the fastest it's going to respond, a circuit breaker, is going to be 20 milliseconds. And you're going to be really, really lucky to get that. Okay. Most of the time, it's 30 to 40 milliseconds. And that's when it's tripping in the instantaneous band. A fuse can trip as fast as 4 to 5 milliseconds. Okay, so automatically you've pulled in your duration. Now, that's an eternity when it comes to arc flash. The second thing the fuse does is it clips the current. Okay, so you'll look at let-through current curves where you'll see perspective current on the x-axis and thousands of amps, and then you'll look at let-through current on the y-axis. So you can have 50, 60, 70,000 amps at perspective current that a breaker would let through, whereas a fuse is going to clip it at like 5, 10, 15,000 amps. So your current goes down and your clearing time goes down. So that's how you're able to get incidental energy down to substantially lower amounts. Plus, the stress and strain on the equipment, you're going to save your asset.
Right.
So if you have an IGBT on the solar inverter that starts an arc flash, and those happen, because remember, a small event propagates elsewhere, you're gonna lose your asset most of the time. So it's not just going to stay within that IGBT or that power module. People call them different things, but it'll go into the entire inverter, and the entire thing will burn down sometimes.
Right. So
you have safety issues and performance issues.
I'm not asking for maybe specifics, but have you been seeing injuries, incidents in this space for some of these reasons?
Yeah, and a lot of these are going to be public knowledge. You can go to OSHA, and look it up. That's probably about all I can say. And
That's fair.
I appreciate your sensitivity on that, but I wish there was more knowledge sharing out there on that. I am sworn by NDAs, and then there's other reasons that are people that are getting involved.
Fair.
But I'll say this: never ever work on anything energized, even if it's 24 volts and a central inverter. Okay, and then there are things to do to go get where you don't have to adjust the PPE issue, where you can go to engineered controls, and they're usually very, very cheap, and in some cases, less than $1,000 per inverter.
Okay, and there's always an engineered solution available or to be discovered.
I've only bumped up where it was just too costly to do.
But it was available.
It was available, yes.
All right.
Yeah. Now, remember, there's always the first, step in the hierarchy of things is elimination.
Elimination.
Yeah. But
right.
do we really, how often do we do that, right? So.
And in solar, I've learned that sometimes that means you need to eliminate the sun. So it's coming at night.
Yes. Working at night is, that's really the only way to do that. If we want it to, it just gets too cost prohibitive in solar to stop at the module level or panel. Some people call them panels, some call them modules. What's going there. So they have combiner boxes, and that's about as close as you can get to isolating that. But you'll see combiner boxes catch fire many, many times, and I've had many people. It's like, well, what can we do to stop that? Well, 99 times out of 100, that's a ventilation issue. just an overheating issue.
Oh,
Yeah.
it wasn't an arc, just heat.
Well, the heat caused the arc.
Yeah.
Yeah. I mean, you live, here in Tehachapi. Are you going to leave your kid in the car or a dog in the car?
It's not a good idea.
It's not a good idea. It gets very hot in the car.
Yeah.
That's because you got a large surface area exposed to the sun. So a combiner box, it's the same way. You can have up to 1,300 watts per square meter absorbed through sheet metal.
Okay.
That's an astronomical lot of heat.
Yep.
So, I mean, we don't even use incandescent bulbs anymore. I mean, how many 100-watt bulbs would that be inside that combiner box? And then when you see it get up to 150, 160, 170 degrees C,
right,
that's just too hot.
Yeah.
And what's the wire rated for? 90 degrees C.
90.
90. Yes. I mean, it says it on the wire. I'm not saying anything secret. It says it on the wire.
Yeah. No, it's been a while since I've looked at it, Joe.
Yeah. So, I mean, if it says 90 and the fuse says terminate at 90, you would want to keep your temperatures below 90.
Typically ventilation on combiner box. The other one I saw were string inverters without disconnect device.
Well, normally on a string inverter, you'll have a switchboard up front of that where you can go switch that off, at that point. I like that.
But DC's still connected.
Yes, that's true.
I saw on some where DC didn't have a switch, went right to the string inverter, and so that means turn off the sun.
Yeah, you meant the DC side. Yeah. I wasn't thinking about that.
Yeah. Let's thank our friends over at Renew Safety, your proactive partner in safety solutions. With comprehensive safety consulting, ensuring compliance with all safety regulations and standards. Expert staffing solutions, providing trained safety professionals tailored to your project's needs. Commitment to sustainability, promoting a safe and sustainable working environment. Contact Renew Safety at info@renewsafety.com and speak to one of their industry experts about their proven track record for safety management on numerous projects. Or perhaps you're looking for construction, safety staffing, contractor monitoring, incident investigation, or program development and training. Check out Renew Safety at renewsafety.com.
I'll tell this story because this has been many, many years, but I was a design engineer for this wind turbine OEM, and we switched from doubly fed induction generator to permanent magnet generators. Well, permanent magnet motors and permanent magnet generators have been around a long time.
Yeah.
Everyone knows you just get a little bit of rotation on it, you're going to have an induced voltage, right? So there's ways that people mitigate that, with shipping and things like that. Now, on a wind turbine, what's there to stop it? The pitch system and the brake.
Right.
And how long is that going to take? A long time. I mean, it might as well be an eternity for when you're dumping energy into something you don't want to dump energy into. So the solar is a lot more forgiving than a rotating piece of equipment, because if you look at the label that's on the module, it'll tell you what your short circuit current is, and it's usually no more than 10% of the nominal current. Okay. For a generator, you're going to look at the subtransient and transient reactances of those generators, which is typically between 10 and 20%. And you're going to look at the X over R ratio, the reactance to resistance ratio. And you're going to have astronomical amounts of fault current coming off that. You might put out 1,000 amps nominally, but under a fault condition, you could put out 20, 30, 40,000 amps. So that's why in a rotating piece of equipment with inertia, bringing that to a stop very quickly was a challenge. So that was a challenge we just didn't think we would need to address until our first fire, and then we realized we needed to mitigate that somehow.
Right.
In solar, I see stuff sit there and cook till the sun goes down. But it's not that violent because the short circuit current is only, like I said, 10% greater than that.
Gotcha. Okay. I always learn so much when I get to talk to you, Joe.
Sorry,
I had to take notes. Now I'm like, I don't know if I got the definitions right over here.
I'm sorry. I apologize.
I love it. Well, I I mean, I think I went back to our episode a few times to find it, recall something. But now our challenge can't be go look for stickers of ANSI C37.20.7 because we aren't going to find people aren't going to find too many of them out there.
And your wind people will.
Wind people will?
They will.
What about solar? What can we ask them to look for that might tie to safety and we can do a giveaway?
Look, that's a good point. For safety, arc flash labels.
Arc flash labels.
Conflicting labels.
Conflicting arc flash.
Yes.
Sounds like we're going to be picking on someone if we find them.
No. I'm not. I'm really not trying to pick on anybody. I'm asking people. Remember, we were talking about Lotto and technicians thinking for themselves and training. This would be good. Every one of my customers would love this. They would love, for technicians to ask these types of questions. Be like, hey, I'm seeing this arc flash label on this front, but the back says this. Which one is right? And then it starts the conversation and the dialogue, because reality, it should be the greater one. So the engineers that represent my customers always tend towards that, of saying go with the greater one.
Okay.
And one thing we haven't figured out in solar is when you bring the AC and the DC together and they're arcing together, Ralph Lee and IEEE 1584 don't really address that. So that's why we say go with the greater. But and I don't even know how to simulate that in a lab, really. Not simulate it, but create it.
Right. I've never heard of it. So.
Yeah.
Okay, well, that's a good one. Arc flash labels, conflicting labels. As those come in, we might have to reach out to you if we have questions we can't answer.
Well, if they see one on the transformer,
right,
they see one on the inverter, and if they're separate devices, then that makes sense.
Fair.
And then ask them to look for the incidental energy, and if it's above 40, consider asking, how far away do I need to stand to
safe
get
distance
to where it is 40. If I don't have this device or something like this, could I? What other things could I do administratively to do a live, dead live verification? Be creative, right?
Yeah, that's a great one.
I've seen some people take a hot stick and switch a small breaker just because that was the only way to get 4 feet away. So, many times a hot stick's reserved for oil switch or different things like that, but somebody was very creative. I was like, I love it. I wish I'd thought of that. Right.
And they're geared up in PP when they're doing it.
They are. Yeah. Or they're outside the boundary.
Oh, well.
You remember? Sure. Well, I'm going to say it all day. The PPE is the last resort.
Yeah.
Getting outside the boundary is preferred anyway.
Right.
Yeah, the PPE is like gravy at that point.
I'm imagining a short boundary. That doesn't make me feel very good, I guess, in this situation, but I understand.
Yeah, I mean, are we putting a lot of stock in people like myself that say it's 15 foot 2 inches?
Yeah.
Right? We're so pedantic with those things, but it all falls down to tests that people have done for the last 30 years.
Right.
I mean, if it said 15 foot 2 inches, I'd probably make it 20.
Yeah.
I'm just saying.
That's what I'm thinking.
Exactly.
Oh, my goodness. I love everything you're sharing about safety this time and additional devices and, in solar, the stacked OEMs working together and celebrating what we're learning now and how we can improve safety.
Yeah. So a lot of times that's going to fall on multiple shoulders.
Yeah.
A lot of different times.
Right. Well, love that you're in the space and showing people new devices and new ways. And if you don't have the good procedure or process, it can be made. It's available. It can.
And, there are companies. Can I give a shout out to one of your guests?
Of course.
Renew Safety.
Renew Safety, yeah.
Yeah. They come in and they help people assess their risk document them, write procedures for them. Remember I said that the preparation phase is the most lacking phase? Well, they help people with that. When they, I've worked with some of their folks, and they do a really good job of that. From that safety perspective, and I think they're a class example of doing that well.
They really are. No, Oscar's the first person I've called for a long time when I need a little help, a little advice, something like that. And no, we love what Renew Safety does. So, of course. How's the book going?
Oh, Wanda. That was a lot of fun.
Yeah.
I did a radio interview not too long ago.
Nice.
Worked with my daughter. It's been good feedback of former colleagues are reading it at their daycares and stuff like that.
Oh, cool.
My intent was to get the next generation interested in working with their hands, and particularly renewable energy. I've advertised it a fair amount. It's gotten some mixed perception.
Okay.
Well, that's what I thought.
I don't know how you get that, but all right.
Yeah, I don't know either. But I'm very pleased with it.
Good.
It's on Amazon, Barnes & Noble, Walmart, so it's still there.
Fantastic. I love it. I love that you try and get the little kids going. I watch my little nephews with monster trucks and stuff. I'm like, how do you get wind turbines and solar panels into those toy boxes? More interest.
Yeah.
Yeah, they're not as fun as a monster truck. But.
No, my grandson loves his monster truck.
Yeah. Yeah, I love it. You got more planned? Will this passion continue?
I don't know. That writing a book is easy. Illustrating it is a little bit more challenging. My daughter illustrated.
Right.
But publishing it and marketing it, we were talking with Jacob earlier, and you guys know what that's
it's a lot
painful
of work.
sometimes.
Yeah.
It is. It was one part of the book that I just underwhelmed. Marketing is a huge industry for a reason.
Yeah. Well, I hope it continues to sell, and the news of Wanda gets out there to all the children around. I love it. I think it's fantastic. We've talked about it a few times. It comes up here and there.
Well, thank you.
Yeah. All right. Well, publishing is the harder part. But you're right. We got to be telling stories and get the next generation engaged.
Yes.
Really. Yeah. I love it. Well, I'm so happy you and your wife came back to Tehachapi and shared with us. I don't know if you had any other items you wanted to cover today.
Well, we talked about safety, and we talked a little bit about power quality. But safety, there's a ACP conference coming up in March.
OMS?
Yes.
Nashville?
Right. And you'll be there, right?
I'll be there. Will you be there?
I'll be there as well.
Okay.
Yep.
Operations, maintenance, and safety.
Yes.
Yes.
Yes. If you wanted to talk about maintenance, I wrote a brief article not too long ago about breaker maintenance.
Love to.
Okay. Well,
yes.
A fuse fails, you replace it, right? But many times a fuse is like a person. You have its life wicked away over time, and then you have the application for the fuse and the fuse holder and all kinds of stuff like that. But in the renewable space, nobody does breaker maintenance. But you go into other industrial spaces, same breaker. Let's talk about an Emax breaker, for instance, okay, made by ABB. Wonderful breaker, and it works every time when it's maintained.
Okay.
Well, so people in the industrial and commercial spaces are very, very religious with their breaker maintenance, and they keep logs and everything like that. So I want to challenge people to think about that.
We're not doing breaker maintenance in our space.
No.
What does it mean to do breaker maintenance? It can't be too complicated.
It is not very complicated. It is not very complicated. So it could be as simple as just replacing the arc chutes,
Okay.
to doing a secondary current injection, to verifying that the trip curves are met. You can do micro-ohming, and you can do mega-ohming. And micro-ohming looks at your contact wear and your pitting. So that's one of the common failures on circuit breakers. It's just the pitting that occurs. And, a number of operations. After you get up to about 5,000-6,000 operations, you're going to want to replace that circuit breaker. Somebody sent me one the other day that had like 36,000 operations on it. It's like when that breaker is asked to do what it's designed to do, it's not going to do what it's designed to do.
That one deserves retirement, probably. Yeah.
Yeah. No, it deserves the cemetery, not retirement.
All right. All right. So breaker maintenance isn't too hard.
No, it's not too hard at all. There's a lot of companies that can do it. NETA, National Electrical Testing Association, talks about the requirements to do that. I mean, they do transformer testing. They're a great organization. People can do it themselves. I got 2 companies that I would recommend. I don't do it. My company doesn't do it. But we could certainly help people out with the procedures to do it. It's not that complicated. I got one customer right now. They sent 6 people to a training class in Dallas, Texas, to do breaker maintenance. So yeah, I'd love to see that done more, and not just breakers, but electrical maintenance. And we think about changing oil and everything like that, or battery change outs are like the most common electrical maintenance thing people think of, right? But cleanliness, cleaning out the cabinet, retorquing, visual inspections, just looking at, do I see anything out of ordinary? A lot of that stuff goes a very long way. And if you're shutting it down anyway to do your mechanical maintenance, look at your electrical as well. Change your filters. Many people try to clean them, stuff like that. Some can be re-cleaned, but if you got a lot of dust on them, there's some areas of our wonderful country that are just notorious for sand, and others notorious for dandelions, and you don't want your equipment to run too hot. Look for hot spots. You'll see stuff start to degrade, and then when you do a very simple dielectric test, that'll show up sometimes, like, I'm starting to wick towards ground a little bit more than I want to.
Some of those maintenance activities I recalled from maintenances that Altair's been doing, right? But yes, it's on those cabinet types, it's clean, a lot of visual inspection, and then some type of an HVAC maintenance, just depending on the type, to ensure cooling. Can't think of a breaker maintenance that has come up in conversation even.
I know. Isn't that weird? That in our industry, it's not done.
There's a lot of breakers out there. Yes.
Every wind turbine has one. Every solar inverter has one.
Yeah.
And it's a very, very simple thing to do.
I'm trying to remember if there was a breaker maintenance on wind turbines. Did we have one?
I know one customer in Sweetwater, Texas, that did a maintenance once.
Oh, well. They got the gold star on the breaker maintenance so far.
Yeah, but I hope that changes.
Right.
I just hope from us talking about it that that changes.
No, you're right. Typically it goes to failure, then gets swapped out.
Yes, and
not often refurbed even.
Yeah, and sometimes when they go to failure, it's a catastrophic failure.
Yeah.
And you lose the asset. And for a solar application, that can be the entire inverter.
Right. Now you need a whole new cabinet assembly.
Yes.
Right.
12-month lead time. Yeah.
Oh,
plus, what if somebody were standing there when it happened? God forbid. Things like that.
Of course. I love it. Oh, that was great on maintenance. Something just came up in maintenance in my life in the last week or two, but it was your post on breaker maintenance. Oh my goodness. Too many. I'm overworking myself, Joe. I think all my thoughts.
You're a busy guy. You
because
really are.
yes, it was your post about breaker maintenance, and I'm always a fan of send your most experienced people to do your maintenance. My entire life, my entire career, and that typically works in most industries, but this industry continues to grow so fast that you can't ever create that. You know, getting caught up with the workforce is so tough that you need those folks doing something else, and it's a challenge.
Yeah.
Yeah.
I mean, the breaker, from a protective standpoint, is probably your most critical component
Right.
that's there. And I'm not talking your molded case circuit breakers. You know, I'm talking your insulated case circuit breakers. Although some molded case circuit breakers can be maintained, but generally your insulated case devices. So, you know, I picked on ABB Emax, but, you know, Schneider, Master Packs, LNS, they can all be maintained. Eaton. So,
Yeah.
so it's not that difficult.
Nope. And I got to take some sort of memory pills to get a little sharper on that. That was good. I love that. I forgot breaker maintenance.
You made me think of it with the acronym for the ACP show coming up in Nashville.
Maintenance.
Yeah, because we had talked so much about safety, but maintenance plays a part of that too. It's part of
Huge.
Yeah, it's a control part, I think.
Yep. That's right. First, protect your people. Second, protect your product.
Yeah, and by protecting your product, you protect your people too.
And then protect your power by calling the power quality doctor. Power quality doctor.
Well, power quality is protecting the equipment too. Which you know, you don't, transformers failing, conductors failing can all be prevented as well.
Right. Very cool. Joe, thank you for coming out.
Thank you, Adam.
I'm going to wrap us up, or else we'll have wives sitting waiting too long.
Yeah, they're going to be happy. Might be getting hangry.
Angry. That's right. All right. Thanks again, Joe.
Thanks.